Continue with the rest of chapter 3. So in our previous class, I have mentioned to you about composite signals. So just to recall back, composite signals can be represented as a combination of simple sine wave with different frequencies, phases, and amplitudes. Okay, so for frequency spectrum of composite signal, we can draw something like this. Okay, which means description of a signal using the frequency domain and containing all of its components. And today we are going to continue still a little bit about composite signal and transmission medium. A signal needs to pass through a transmission medium, cable or air. In case of wireless transmission, we use air. Okay, a medium may pass some frequencies and may block or weaken others. When we send a composite signal containing many frequencies, we may not receive the same signal. Okay, if you refer to this figure, okay, on your left is the input signal that is fed into the transmission medium, and then this is the output signal. Okay, you can see here, the output signal is no longer exactly what we fed into the transmission medium. Why? Because of the medium may pass some frequencies and may block or weaken others. Kabel biasanya dia akan hanya membenarkan frekuensi tertentu sahaja untuk lalu melalui ya, dan ada kalanya dia akan block dan akan melemahkan certain signal pada certain frekuensi. Okay, so that's why bila kita bagi input signal, terutamanya signal yang melibatkan composite signal, output yang akan diterima di sebelah receiver is no longer exactly what we have sent. Okay, next. I want to highlight about the term bandwidth. Okay, apakah itu bandwidth? Normally referred to as the difference between the highest and the lowest frequencies of a composite signal. If we try to relate the term bandwidth to a composite signal, dia adalah perbezaan di antara highest and lowest frequency. Maksudnya frekuensi maksimum tolak dengan frekuensi minimum. So if a medium can pass frequencies between 1000 and 5000, its bandwidth is 5000 minus 1000, which is 4000. If the bandwidth of a medium does not match the spectrum of a signal, some of the frequencies are lost. So untuk membolehkan satu signal tu lalu melalui satu-satu kabel ataupun medium, spektrum dia mestilah mesh di antara keduanya. Okay, apa maksud saya mesh tu? Okay, we try to look at the example later. Okay, now let's consider this one first. If a periodic signal is decomposed into 5 sine wave with frequencies of 100, 300, 500, 700 and 900, what is the bandwidth? Okay, so very simple. So you recall the definition for bandwidth. So definition, the difference between highest frequency minus lowest frequency. So 900 minus 100. So the bandwidth is 800 Hz. Okay, draw the next part of the question. Draw the spectrum, assuming all components have a maximum amplitude of 10 volt. Okay, so you just plot using frequency domain. Okay, so amplitude 10. So all have a same amplitude, 10, and then just draw one spike. This one is known as spike, S-P-I-K-E, spike. Okay, satu garis lurus ni kita panggil spike. So this is the final spectrum of this composite signal. Okay, next example. We consider this question. A signal has a spectrum with frequencies between 1000 and 2000. So, but the bandwidth, if we calculate 2000 minus 1000, the bandwidth is 1000 Hz. A medium can pass frequencies. Okay, satu signal frekuensi dia 1000 hingga 2000 Hz. Okay, bermakna bandwidth dia adalah 1000. Okay, and then another a medium can pass frequencies from 3000 to 4000. Bandwidth is also 1000. Dan kita ada satu kabel yang membenarkan frekuensi di antara 3000 hingga 4000 lalu melaluinya. Okay, so the question, can this signal faithfully pass through the medium? So soalan dia tanya, adakah possible untuk signal ini melalui kabel yang disebutkan? Kerana, okay, kalau kita tengok dia punya bandwidth, if we look at the bandwidth, both of them, the cable and the signal, kabel dengan signal tu kedua-duanya, they have the same bandwidth which is 1000 Hz. Tetapi persoalannya, adakah boleh signal tu lalu melalui kabel tersebut ataupun medium tersebut. So berbalik kepada statement yang saya sebut tadi, the frequencies must match. Frequencies of the cable and the frequencies of the signal must match so that the signal can pass through the medium. Okay. So if the bandwidth of a medium does not match the spectrum of a signal, the frequencies are lost. So dalam case ni, the answer is no. Because kalau you tengok, the frequencies range of the signal is from 1000 to 2000, but the frequency spectrum of the medium is 3000 to 4000. Maksudnya dia tak match. Okay. Yang tu signal sehingga 2000, tetapi medium boleh support from 3000 to 4000. Walaupun bandwidthnya sama, nilai, tetapi range-nya tidak sama. So signal tersebut memang totally tidak dapat lalu melalui medium. Okay. So this is just the drawing I want to show you how to draw the frequency spectrum of a periodic signal and the bandwidth of a non-periodic signal. Okay. Okay, next we move to digital signals. Okay, previously we have seen analog signals. So analog signals, just to recall back, we have three elements when we are drawing an analog signal. We consider amplitude, we consider frequency, and we consider phase, and we have done some calculation based on that. So now we move to digital signals. One can be encoded as positive voltage and zero as zero voltage. So bila kita consider digital signal, satu akan dilukis sebagai positive, zero sebagai zero voltage. So most digital signals are aperiodic and thus period of frequency is not appropriate. Okay, kebanyakan digital signal dia aperiodic. Aperiodic maksudnya dia tidak ada pattern yang dia repeat over time. Okay, kalau you tengok pattern dia tidak seragam seperti sine wave. Okay, yang kita tengok dalam analog signal. Jadi pengiraan untuk period dan frekuensi is not applicable for digital signal. Period and frequency hanyalah untuk analog signal. Okay, so for digital signals, we have to consider another two terms which are bit interval, okay, sebagai ganti kepada period, and bit rate instead of frequency, okay, to describe digital signals. Okay. So we're going to look at definition for bit rate and bit interval. Okay, bit rate refers to the number of bit intervals per second. Okay, or the number of bits sent in 1 second, usually expressed in bits per second, BPS. Okay, bit rate ni adalah bilangan bit yang boleh dihantar dalam masa 1 saat. Dia merujuk kepada kelajuan jugalah sebenarnya. Okay. So unit dia adalah BPS. So kalau macam biasa kita nak consider internet connection kan, kita biasa tanya okay, berapa kbps, berapa megabit per second. Tu sebenarnya adalah berapa banyak bit yang boleh transmit dalam masa 1 saat. Itu adalah bit rate. Okay, bit interval is the time required to send one single bit. Okay, whereby masa yang diambil untuk menghantar satu bit, we call it bit interval. Okay, let's consider the figure below. So, you have, okay, from here to here, okay, the time taken is 1 second. And then as you can see, there are 8 bits in this figure, okay. So, in 1 second, 8 bits can be transmitted. So meaning that the bit rate is 8 bit per second. 8 BPS. That is the bit rate. Okay, and then the bit interval. Okay, bit interval. In 1 second we have 8-bit interval. So the time taken to send 1 bit is 1/8 second. Okay. Okay, let's consider this question. Okay. A digital signal has a bit rate of 2000 bps. Okay. So, given to you the bit rate, what is duration of each bit? Okay, bit interval ataupun sometimes dia panggil juga sebagai bit duration ataupun duration of each bit. Okay, dalam exam kalau dia sebut bit duration, samalah maksudnya dengan bit interval. So, bit interval, okay, for this question, 1/2000. So, equal to 0.000500 second. Or, if you are confident enough to convert it to microsecond, you can, okay, from second to micro, daripada unit yang besar ke unit yang kecil, you akan darab dengan 10 kuasa. Okay, kalau micro sepatutnya 10 kuasa -6. Tapi disebabkan conversion tu daripada second, okay, unit yang lebih besar kepada micro, unit yang lebih kecil. So, kita buang tanda negatif dekat micro tu. Okay, so dia akan jadi 500 microsecond. Okay, next we move to transmission of digital signals. We have two different approaches for the transmission of digital signals: baseband transmission and broadband transmission. So what is baseband transmission? Baseband transmission means sending a digital signal over a channel without changing digital signal to an analog signal. Maksudnya signal tu asalnya dalam bentuk digital, kita hantar je dia dalam bentuk digital. Okay. Kita tak proses dia, convert dia kepada analog. Okay, itu adalah baseband transmission. Okay, so requires low pass channel. Okay, apakah itu low pass channel? Channel with a bandwidth that start from 0. Okay, we will see later. Then another one approach is broadband transmission. We call it modulation. Okay, broadband transmission means changing the digital signal to an analog signal for transmission. Okay, yang ni kita ada digital signal dan kita akan hantar dia dalam bentuk analog. Jadi dia perlu melalui proses modulation. Okay, saya ada sebut awal-awal itu proses conversion of digital signal to analog, we call it modulation. So for broadband transmission, we can use band pass channel, which is channel with a bandwidth that does not start from 0. Okay, so okay, let's consider this figure first. Okay, the difference between low pass and band pass channel. Okay, on the top is low pass channel. Low pass channel ni dia adalah satu channel yang mana bandwidth dia start daripada kosong sehinggalah berapa pun. Dia punya maximum can be any frequency. Okay, that is low pass channel. Dia mesti bermula daripada kosong. Tetapi untuk band pass channel dia boleh bermula daripada mana-mana frekuensi dan berakhir di mana-mana frekuensi juga. So, what is the implication? Okay. So, if we look at this figure, kalau semua channel nak bermula daripada kosong, that is not possible, right? Okay, semua orang nak start di starting point yang sama, it is not possible. Siapa yang nak start daripada tengah? Okay, so that's why it is mentioned here, this type of channel, okay, refers to band pass channel, is more available than a low pass channel, which can be divided into several band pass channels to carry several analog transmission. Jadi, broadband transmission is more preferable because the band pass channel is more available. Of course, bila kita consider band pass channel, lebih mudah untuk kita cari band pass channel sebab dia boleh, it can start with any frequency and ended with any frequency. Okay, so kita tak pergi detail. Okay, so hanya you perlu tahu perbezaan, the difference between baseband transmission and broadband transmission, and apa channel yang diguna dan kenapa broadband transmission is more preferable, because the type of channel is, the band pass channel is more available. Okay, next we move to transmission impairment. What is transmission impairment? Maksudnya defect. Lebih kurang macam defect. Signals travel through transmission media which are not perfect. The imperfections cause impairment in the signal. Okey, kabel yang membenarkan signal lalu adalah tidak perfect. Okey, dia ada rintangan dalam kabel tu. So, ketidaksempurnaan kabel tu dia akan mengakibatkan ketidaksempurnaan juga bagi signal yang lalu. So, the signal at the beginning of the medium is not same as the signal at the end of the medium. So, the implication, signal at the beginning, apa yang dihantar tidak sama dengan apa yang diterima. Okay. Okay, so we have three categories of impairment: attenuation, distortion, and noise. So what is attenuation? Attenuation means loss of energy. When a signal travels through a medium, it loses some of its energy so that it can overcome the resistance of the medium. So as I said, there is resistance in a medium. So dalam setiap kabel dia ada rintangan. Dan apabila signal lalu melalui kabel, dia harus mengatasi rintangan tu, dan dengan itu dia punya energy akan loss. So that is why a wire carrying electrical signals get warm or hot after a while. Some of the electrical energy in the signal is converted to heat. So what is the solution? Amplifiers used to amplify the signal. Jadi untuk menguatkan kembali signal tu, kebiasaannya kita akan gunakan satu komponen yang dikenali sebagai amplifiers. Okay, so analoginya macam kita lah, bila kita berjalan, kita mengatasi geseran dekat kaki, so kita akan lost energy. So sama juga dengan signal. And then distortion, the signal change its form of shape occurs in a composite signal made of different frequencies. Okay, distortion, perubahan dari segi bentuk. Each signal component has its own propagation speed through a medium and its own delay in arriving at the final destination. So, perubahan bentuk ni kebiasaannya berlaku pada composite signal. Kenapa? Sebab composite signal dia terdiri daripada signal yang pelbagai frekuensi. Jadi, bila perbezaan frekuensi tu, dia akan menyebabkan different propagation speed apabila melalui medium atau melalui kabel, dan setiapnya akan ada delay tertentu. Okay, next one is noise. Several types of noise such as thermal noise, induced noise, crosstalk, and impulse noise may corrupt the signal. Okay, kebisingan noise. Okay, so thermal noise means random motion of electron in a wire which creates extra signal not originally sent by the transmitter. Okay. Second one, induced noise comes from motors and appliances. Kalau kita letak kabel tu berdekatan dengan motor ataupun peralatan elektrik lain, dia akan ada induced noise. Then crosstalk, the effect of one wire on the other. Bila dua wire bersebelahan, okay, akan wujud induced noise. So the effect of one wire on the other is crosstalk. So induced noise comes from motors and appliances. And then last one is impulse noise. Okay, this is due to spike signal with high energy in a very short period of time that comes from power lines, lightning, etc. Okay. Okay, then we come to calculation part. Okay, signal to noise ratio. Okay, what does it mean by SNR, signal noise ratio? A high SNR means the signal is less corrupted by noise. A low SNR means the signal is more corrupted by noise. So you have one formula. SNR is the ratio of average signal power over average noise power. So average signal power divided by average noise power. Bahagi average signal power bahagi average noise power. So kalau tinggi SNR tu bermakna signal itu lebih kuat berbanding kekuatan noise yang affect. Okay. Okay. So simple je. When you are given any question related to SNR, just apply the formula. So we consider this one. The power of a signal is 10 milliwatt and the power of the noise is 1 microwatt. What are the values of SNR? Okay, so let's solve this. Okay, So power of signal 10 milliwatt. Power of signal 10 milliwatt. Okay, over power of noise 1 microwatt. Okay, so we convert to watt times 10 to the power of minus 3. Okay, divide by 1 times 10 to the power of minus 6. Okay, so the answer is 10,000. Okay, so ratio doesn't have any unit. Okay, so the answer just now is 10,000. Okay, next we move to data rate limits. Okay, so what is data rate? So bit rate, actually data rate depends on 3 factors. The bandwidth available. And, of course, if we have large bandwidth, we will have large data rate. The levels of signal we can use, then the quality of the channel, the level of the noise which affecting the channel. Okay, so we have another 2 more formulas. Noiseless channel. For noiseless channel, we have Nyquist bitrate formula. Okay, bitrate equal to 2 times bandwidth times log 2L. Okay, log L to the base of 2. So L is the number of signal levels used to represent data. Okay, so for example, we have 1, 0, 1, 1, 0, 0, 0, 1. Okay, so we have 1 bit only. So can either be 0 or 1. So level is only 2. So bit rate is 8 bit per second because we have 8 bits sent in 1 second. Okay, for the second figure, this is a digital signal with 4 levels. Okay, because we have 2 bit, so the level, so there are 4 possible combination, either 0, 0, 0, 1, 1, 0, and 1, 1. So that is why we have 4 levels here. Okay, so kalau dulu you have to remember the formula. So since this is we will have open book test and open book final also maybe. So you don't have to remember the formula. You can just open your notes and just apply the formula. Okay. This is for noiseless channel, means the channel is not affected by noise. We consider it as ideal channel. Okay, channel yang tidak dipengaruhi oleh sebarang noise. So channel yang perfect lah. Okay, so let's try this example. Consider a noiseless channel. So biasa soalan akan mention noisy or noiseless channel with a bandwidth of 3000 Hz transmitting a signal with 2 signal levels. What is the maximum bit rate? Okay. Okay, so just apply the formula. Okay. So the formula is 2 times bandwidth times log L to the base of 2. Okay. Okay, so should write bit rate equal to, so given in the question, so the bandwidth is 3000 Hz and the level is 2, log 2 to the base of 2. Okay, so since base log 2 to the base of 2, so the answer is 1. So the answer here is 6000 and bit rate, the unit is BPS. Okay, another question, I show you. Consider the same noiseless channel transmitting a signal with 4 signal levels. What is the maximum bit rate? Okay, this is for number 1. Okay, number 2, just apply the same formula. Okay, the same So bit rate equal to 2 times bandwidth. Bandwidth yang sama. But the signal levels, instead of 1 bit, kita gunakan 2 bit. Jadi 4 levels. Okay. So 4 levels. 4 signal levels. Okay. So you just substitute L value. Okay. 4. Okay. This one 6,000. Okay. Log 4 to the base of 2. You boleh congak je ataupun konsepnya macam ni sebenarnya. Log 4 to the base of 2 ialah log 4 to the base of 10 divide by log 2 to the base of 10. So the answer is the answer for this part is 2. So finally we have final answer is 12,000 equal to kilohertz. Okay, so kalau you press your calculator, you tak boleh press log 4 macam tu sebab dia dalam your calculator is actually log dia tu log base 10. Okay, so kalau you nak kira untuk base tu, you have to convert to this form. Okay, kena tukar dalam bentuk ni lah. Kalau log 4 to the base of 2 sebenarnya you kena convert jadi log 4 to the base of 10 divide by log 2 to the base of 10. Maksudnya yang atas ni dia akan letak kat atas log 4 to the base of 10 bahagi dengan log 2 to the base of 10. Okay, next let's try another one. Okay, example, we need to send 265 kbps over a noiseless channel with a bandwidth of 20 kHz. How many signal levels do we need? Okay, tadi dia suruh kita cari bit rate. Okay, diberi bandwidth dengan level. But now dia bagi the bit rate is given to you, already given to you, and the bandwidth, and then you are asked to find the level. Okay, so how you have to manipulate you have to rearrange a little bit the formula. Okay, let's do this. Okay, for number 3. Still the same formula. Bit rate equal to 2 times P times log 2L. Okay, so the bit rate given is 265, right? So 265 kbps. 265 kbps. So I change it to this form. Okay, low. Okay, then times with the bandwidth is 20 kilo. Okay, okay, times log 2L. Okay, so I can write it in this way. Log 2L equal to 265,000 divided by 40,000. Okay, so using a calculator, okay, 265 divided by 40, so I will get 6.625. Okay, 6.625. Okay, so how to get L? 6.625 equal to log 2L. So L equal to 2 to the power of 6.625. Okay, equal to. Okay, so the answer is 98.7. 98.7. 98.7. So just write it as 99. Okay, next we move to another formula. This is noisy channel. Okay, just now we consider the channel is perfect enough, so it won't be affected by noise. So now we consider another formula, Shannon capacity formula for noisy channel that can be affected by noise. So the formula capacity, okay, also in bit per second, equal to bandwidth times log 2 1 plus SNR. Okay, so let's do it together. We have a channel with a 1 megahertz bandwidth. The signal to noise ratio is 63. What is the appropriate bit rate? Okay, so try this one. So formula, apply the formula. So capacity equal to bandwidth times log 2 1 plus SNR. So given the bandwidth is 1 mega, so mega is 10 to the power of 6. Okay, log 2 1 plus 63. So 1 times 10 to the power of 6 log 64 to the base of 2. So if you calculate this one, log 10, okay, ataupun you boleh corak je sebenarnya. Okay, 2 kuasa berapa? 64. 2 kuasa 6, right? Okay, so you akan dapat 6 megabit per second. Okay. Okay, next one. Next one, I think you can try on your own. Okay. Next, okay, now we talk about performance. Okay, performance of the transmission consider about bandwidth, throughput, latency, and jitter. Okay, these 4 elements. So what is bandwidth? Bandwidth tadi kita kata the difference between the maximum frequency and the lowest, the minimum frequency. So bandwidth in hertz, okay, bandwidth actually we can express in hertz or bandwidth in bit per second. So bandwidth in hertz means a range of frequencies contained in a composite signal, or the range of frequencies a channel can pass. Okay. Another concept of bandwidth is bit per second. Number of bit per second that a channel or even a network can pass. So of course, an increase in bandwidth in hertz means an increase in bandwidth in bits per second. Of course, kalau kita consider analoginya, highway semakin luas jalan ataupun highway, semakin banyaklah kereta yang boleh lalu. So samalah juga dengan kalau the range of frequencies is wide. So the number of bit per second that a channel can pass also more. Okay, next, throughput. Throughput actually is a term to measure how fast we can actually send data through a network. Okay, bandwidth in bit per second and throughput seem the same. Okay, so tadi kita tengok bandwidth also can be expressed in bit per second, number of bits a channel can pass. Okay, nampak sama seperti throughput, but they are different walaupun unit yang digunakan adalah sama. Okay, a link may have a bandwidth of B bit per second, but we can only send T BPS through this link. Okay, T always less than B. So the difference is B bandwidth is potential measurement of a link. Throughput is the actual measurement of how fast we can send data. Okay, contohnya analoginya macam ni. Okay, contohnya satu bilik kuliah boleh memuatkan 30 pelajar. Okay, kapasiti dia boleh muat 30 pelajar. So kita boleh consider itu sebagai bandwidth. Okay, sebagai analoginya sebagai bandwidth. Dan contoh bilangan pelajar kelas saya hanya 28. Okay. Penggunaan sebenar peralatan kursi meja dalam kelas tu hanya 28. Sedangkan dia punya kapasiti boleh pergi sehingga 30. So kapasiti sebenar adalah kapasiti yang boleh memuatkan pelajar tu adalah 30, tapi jumlah pelajar hanya 28. So, kapasiti yang mampu ditampung tu kita consider as the bandwidth, which is the potential measurement of a link, and throughput tu adalah the actual measurement of how fast we can send data. Maksudnya yang sebenarnya yang actual measurement adalah throughput, tapi potential dia adalah bandwidth. Okay, next, latency, another term which relate to performance, also the latency. How long it takes for an entire message to completely arrive at the destination from the time the first bit is sent. Okay, ni saya let's see the drawing. Okay, let's say I'm sending a data from A. Okay, the source is A, and then the receiver or destination is B. Okay, let's say I have a certain data to send. Okay, so for simplification, let's say I want to send only 4 bits of data. Okay, X here, Y. Okay, then it is send 1, 2, 3, 4. Okay, X, Y. So delay is the time taken. Okay, how long it takes for entire message to completely arrive at the destination from the first bit is sent. So delay itu adalah masa yang diambil daripada first X, okay, first bit ni, X ni keluar, sehinggalah Y ni fully arrive at destination. Okay, the last bit is successfully received by destination. That is the delay or latency. And then the last one, not the last one, we have also queuing time. Okay, so what is queuing time? Time needed for each intermediate or end device to hold the message before it can be processed. Okay, kalau kita tengok, if you still remember, try to recall back chapter 2. Chapter 2, the last part of chapter 2, I have given you the exercise to draw the format of message in network layer and data link layer. So kalau kita tengok dalam tu ada router kan, daripada source nak pergi ke destination tu dia perlu melalui intermediate nodes, perlu melalui beberapa router. So masa yang diambil untuk router, okay, intermediate device memproses certain data yang diterima, sebab bukan hanya satu, bila dalam when we consider network, banyak komputer akan send and receive data. Okay, dalam satu network yang besar. So router tu bukan hanya memproses data daripada satu atau dua komputer sahaja, tetapi mungkin beribu-ribu komputer kalau kita consider network yang besar. So bila banyak data yang perlu diproses ataupun packet of data yang perlu diproses oleh router, it will take certain time, and mana-mana data yang sampai dulu, it will be processed first by the router. So dia perlu beratur. Macam analoginya bila you nak bayar barang di counter dekat supermarket, you have to queue. Kalau orang ramai, you have to queue longer. So samalah dengan network. Kalau network tu sibuk, okay, network congestion, the data has to queue at router at the intermediate node. So the queuing time is not fixed. It depends on the load imposed on the network. So queuing time tu dia tidak fixed nilai dia. So when there is heavy traffic, the queuing time increases. Okay, the last part for this chapter 3 is jitter. Okay, jitter I have mentioned also in chapter 1, a problem when different packets of data encounter different delays and the application using the data at the receiver side is time sensitive, usually audio and video data. So dia berkait juga dengan performance. Okay, jitter ni. Okay, yang ni bila kita nak tengok online streaming video audio, kita akan nampak jitter tu. Okay, yang you panggil buffer tu lah. Okay, disebabkan oleh different packets of data encounter different delay. So packet yang sampai kepada device you, dia punya packet tu berbeza delay dia, jadi you akan experience jitter. Okay, dan dia ketara bagi aplikasi yang melibatkan real time ataupun time sensitive seperti audio dan video. So I think that's all for chapter 3.